All right, guys, we're live. So, what we saw in the warm up is that we can't always solve, or we can't always find zeros by graphing or by factoring. This needs us to need something different. The tool that we're going to use to help find x-intercepts is called the quadratic formula. Now, I'm going to just put up the quadratic formula here. You'll always have it. It'll be on your test. Most of you guys will have it memorized because you use it so much. Here it is in all of its glory. To find and it's just a formula that finds x-intercepts for you. So it's a little beefy. I mean, it's on the front left board. I'll talk about that in a second. On the bottom of this formula, you're dividing by 2 times whatever the a value is. That's the nice part. On the top of this formula, you take the negative of b. Did I give you guys this? You guys have this, right? Okay, so we're following along. Now, many parabolas have 2 x-intercepts. We get 1 x-intercept by adding the following, and we get another by subtracting the following. Some of you guys, this is new notation. You've never seen this before. This just means there's like basically 2 answers to this formula, one by using plus, one by using minus. What do you add and subtract? This stuff. So inside a big square root, you take b squared and you subtract 4 times a times c. This is a quadratic formula. It's a formula that gives you the x-intercepts of a quadratic function, or it helps you solve an equation, ax squared plus bx plus c equals 0. Now, where this formula comes from is not part of either course. It's not required for you guys to derive this formula where it comes from. I have derived where this formula comes from on the left board. You don't even have to look at it if you don't want to. It might hurt your eyes. The way I derived that formula was just using some perfect square trinomial factoring skills and some solving for x skills. But you don't have to know how to do that. I'm just making sure that you guys are clear on that. But I also didn't want just to pop out of nowhere and say it's just magic. No, you can derive this formula by getting x by itself with some clever factoring. All right. If you want to just pretend the last 90 seconds of history didn't exist, that's fine. And let's just move on. Here is a quadratic formula. Let's verify that it works. You guys worked with this function in the warm-up. It was the one on the front. We already know what the x-intercepts of this function are. It was 1 and 5. Let's take the quadratic formula for a spin. For some of you guys, it'll be your first test drive of the quadratic formula, and verify it works. Now, no matter which course I teach, I always at least start off by just giving some structure to using your quadratic formula. I'm not your dad. You can do whatever you want, but I think this will help a lot of people. The first thing I would usually encourage my students to do is just pick off the values you're using in the formula. Pick off the a value. Here it's 1. Pick off the b value. Here it's -6. Pick off the c value. The last number is 5. So we know what to plug in. And then there's 3 parts to the formula. The first is -b. So I just have a spot for this. If b is -6, the negative of -6 is +6. If you would just rather write down 6 in that spot because you recognize, okay, the opposite of -6 is +6. This is not necessary to write down. And then the third part of the formula is on the bottom, 2 times a. I mean, I know you guys all know what 2 times 1 is, but, I'm just going to show this work here. You do 2 times the a value. So that's 2. Again, you could just write down 2 if you get it. This third part of the formula has a special name. We'll give it later. This b squared minus 4ac bit is very important. And this one I will show a bit of work because there's a few talking points. So b is -6. So we'll do -6 squared minus 4 times 1 times 5. A is 1, C is 5. Now, most of you guys have a display calculator. where you can see what you're punching in. You could punch in literally what you see there using brackets, and it will spit out an answer for you. Some of you guys are not using a display calculator. You'll need to do this in multiple steps. I would square 36, negative 6 first. That gives positive 36. And can we just all take a moment and just make sure we all understand when you square a negative, you get a positive. Nobody should ever get a negative when you square something. Never negative. Now, even though I made a special point of talking about that, some of you guys will still do it, but hopefully less of you now. And minus 4 times 1 times 5, that's minus 20. Just multiplying them out. And 36 minus 20 is 16. So whether you do it in 1 or 2 steps, we should get 16. Somebody can nod and smile if they got 16 as well. I think it's 16. So use your calculator. The display calculator can do this all at once, or do 2 steps like me. All right, so we're ready to find our first x-intercept. So the quadratic formula says, and this is how I like to do it, I like to put x1 for my first 0. The formula says you take the negative of b, so we found that to be 6. And then the quadratic formula says to get one answer, you add the root of b squared minus 4ac, we got 16. And then you get that answer and you divide that by 2 times a, which is 2. To me, I like breaking it up this way. If you plug everything in at once, sometimes that can be overwhelming for some people, not everybody. And now here, you can show as many steps as you need to. The root of 16 is exactly 4. 6 plus 4 is exactly 10. 10 divided by 2 is exactly 5. Show less steps if you're comfortable. But be careful, it's order of operations. Dividing by 2 is the last thing you do. And the second 0 you get by doing the same thing, but you do subtraction. So 6 minus the root of 16 divided by 2. And I'm going to show all the steps. Show less steps if you're comfortable. The root of 16 is exactly 4. 6 minus 4 is exactly 2. And 2 divided by 2 is exactly 1. Now, if you guys go and look at that half-page motivation, was 5 and 1 our x-intercepts? Yes. Yes, the answer is yes. 5 and 1 were our x-intercepts. The quadratic formula works. You guys convinced it works? It works. And for those of you who don't like factoring, you have another option now. The quadratic formula gives you your x-intercepts, no factoring required. All right. Now this is one where we got nice whole number answers. Let's give the quadratic formula another spin, and let's find the x-intercepts for that one we couldn't factor. See how everything ties together, the warm-up and the lesson sheet? Like, this is master planning by yours truly. But enough pumping my own tires, let's continue. I'm going to use the structure here. I do have a talking point. There is a difference in expectations between the 3U and 3M courses in terms of how we state the solutions here. So if you want to work ahead a little bit, that's fine, but I do have some things to talk about with both groups. But let's proceed. 1, 6, 7 is our ABC. The negative of B would just be negative 6, negative this time. 2 times 1 is 2, last time that I checked. And then B squared minus 4AC. What is that? So that would be 6 squared minus 4 times 1 times 7. So do it in 1 step, do it in 2 steps. I don't really care. Just make sure you can do it accurately. 6 squared is 36. 4 times 1 times 7, and with the negative, makes 28. So I got 8. For my thing under the square root, I got 8. Everybody can do this. Nothing we're doing is crazy, complicated. It's just using a formula. It's a complex formula, but everything is manageable. First zero, we take the negative of b, which we said was negative 6, and we add the root of that b squared minus 4ac, we said with 8. And then we divide by 2 times a, which was 2. Now, for the second one, and this is where I'd like to talk to the 3u people for a second. Whoops, that'd be minus root 8. 3u people. These are what we would call the exact roots. Can you guys jot that down? The 3m people, that's not so important. There are going to be situations in your math careers, 3u people for 4u functions, where you will be asked for exact roots. These are the exact roots. The root of 8 is a decimal number that doesn't terminate. These are the exact roots. For the 3m people, you are just expected to find the decimal approximation of these values. So now let's use our calculators and get what is that as a decimal. My preference for all you guys would that you guys would have a display calculator, and you could do this all in one step to keep all the accuracy. If you need to do it in a couple of steps, that's fine. I'll do these ones in a couple of steps. Like on the top, when I put in negative 6 plus the root of 8, what do I get? Negative 6 plus the root of 8. And on my display calculator, I can see what I'm punching in. I get about negative 3.17. And then I have to divide that by 2. And that's about negative 1.59. Did you round to negative 1.6? Did you round to negative 1.58? I don't really care as long as you got. Did you get something similar? Everybody get something similar? Yeah. Okay. You've got to be careful that you do the top first and then divide by 2. If you didn't get negative 1.59, maybe you should call me over in a sec and show you. I can show you what happened. The second one I'll do in 2 steps as well, but doing it in 1 step is totally fine. So negative 6 subtract the root of 8 is about negative 8.83. And when you divide that by 2, you get about negative 4.41. And these we call the approximate roots. We had to round. They're pretty good. They're pretty good approximate roots. Those are basically where the x, I can't spell today. Apologies. Approximate. There we go. So 3u people, you will be expected to state exact roots, and tomorrow's lesson actually is more about those. The 3m people, you will always only be concerned with the decimals, okay? Now, can you guys flip back to the warm-up? Do those line up pretty well with the graph of where the x-intercept should be? Around negative 1.5-ish and negative 4.5-ish? Let's check. Let's check. Now, like an imperfect graph, but yeah, negative 1.5-ish, negative 4. It looks like it works. You guys convinced it works? It works even if you can't factor. Life is good. We can now find x-intercepts all the time, no matter whether we can factor or not. And guys, that is this is 80% of the lesson is done. We have introduced the formula, we have reviewed the formula, and now we just want to get some practice using it. So let's continue. Can you guys give it a try with this one? For the following 3, we might kind of move into you guys do a lot of work, and I'll come along for the ride, and I might talk about something, but you guys can start doing this. You don't need me to do everything for you. Why don't you guys start trying? And I've actually sketched this parabola so you can check about what the x-intercepts are. It looks like if you did this one right, you should get about 5 and maybe negative a half or something like that. So you guys begin, and I will play catch up in a second. I have caught up with our three chunks. The negative of -9 is +9. 2 times 2 is 4. Those don't require work. You can just write those in. I am going to show those steps for a while. You got to be careful calculating b squared minus 4ac. There's a lot of negatives floating around. You just have to be careful with your numeracy skills. You square a negative as always a positive. You got -81. Shame, shame, shame. +81. Put your base in brackets, like Miss Answers taught you back in grade 9. And then careful here. -4 times 2 times -4. The double negative would make that adding 32. Careful with the signs. So we get 113. 113 doesn't square root nicely, so it looks like we're going to get approximate roots here, some decimal values. I'm going to wait 30 seconds before I continue. You guys start. All right, so for you people, if you were asked for the exact roots, these would be the exact roots. But let's find what the actual approximate roots are so we can kind of check with the graph I have there. Now, at this point, I am just going to put this into my calculator in one step. 9 plus the root of 113 divided by 4. I got about 4.9. Looking at my graph, that seems pretty good. For my second root, 9 minus the root of 113 divided by 4, I got about -0.4. I'll just leave it to one decimal place, which looks pretty good too. Everything matches up. 9 minus root 113 first, get an answer, then divide by 4. If you didn't get those, I'll do a tour right now and you can flag me down. Where we want to get to today, everybody, so 2D people did this. You want this to come back and you want using the quadratic formula to be automatic. Hopefully it already is at this point, but you get one nice day of bonus to make sure it's good. The 3F people, you just got to keep practicing today and developing this comfort level so you can use the formula quickly and accurately and efficiently. You guys do the next one. I will come along for the ride in a second. I'm going to walk around the room. Can you flag me down if you need some tech assistance? Man, can you check that in again?
For him, it's easier.
Oh, I got it now.
Why did you? Oh, so you're being naughty. Okay.
Look at your hand right now.
If you've got this one, the next one done, make sure the people around you are okay. Guys, can we just talk about, look at this one is a problem with one x-intercept, right? Wonder what will happen. Doesn't the quadratic formula give you 2? One with plus, one with minus? How does that work? Who can say? I don't know. I don't know. It's a mystery. Let's unravel it. All right, not sure if I unpause for the previous one, but if you're at home watching, you can just pause and make sure you're good. All right, I'm playing catch up, everybody. Here we go. 1, 6, 9, -6. b squared minus 4 times 1 times 9. Did you guys get 0 for b squared minus 4ac? Aha, look. So no matter how far you are, if you have worked farther ahead, please follow along here because this ties into the summary at the end. B squared minus 4ac was 0. So when you add the root of 0 and divide by 2, or whether you subtract the root of 0, would you guys agree adding 0, subtracting 0, it's the same thing, right? You get the same x-intercept both ways. They both give you -3. Yeah, they both give you -3. All right, so you guys know what to expect when there's two x-intercepts. You add, you get one thing, you subtract, you get a different thing. If there's one x-intercept, the quadratic formula still works. It just spits out the same x-intercept, which is good. We don't want the quadratic formula to break down in some way. So it gives you your one x-intercept. Check out the last one here if you haven't done this one yet. So I have graphed this quadratic function. Now everybody here should be familiar with the fact that not every quadratic function has x-intercepts, right? This one opens up and its vertex is above the x-axis. Would you guys agree this one has no x-intercepts? Well, it would be weird if the quadratic formula gave you x-intercepts. So somewhere along the way, the quadratic formula is going to break down. Because it would be strange if your quadratic formula gave you a couple of zeros when there aren't any. So that's what we're looking at next. If you've already kind of seen what happens, don't spoil the fun. But if you haven't yet, investigate, just go with the process, try to find x-intercepts. At some point, something's going to break down. A is 1, B is 2, C is 4. Negative B is -2. 2 times 1 is 2. Got to go? I'll post the video for the rest. And then, Grace, you might as well just take practice. Practice as much as you need to. And then these are just blank templates in case you want to confuse you. I'll report the last one. Hey, did you guys get -12 for b squared minus 4ac? No? What'd you get? So 2 squared is 4, subtract 16. I'll come back. See what you did? All right, so what happens if you try to continue? Let's just pretend you didn't see where this was going. You're like, okay, I'm just a robot and I just do what I'm told and I'm going to keep going. -2 plus the root of -12 all divided by 2. And maybe you still don't see what's wrong. So then you just try to do -2 plus the root of -12 on your calculator. And mine gave me a math error. Did you guys get that as well? Yes. Math error. Why did we get? What's the issue? Why didn't our calculator spit out an answer? Madeline? You can't square root a negative. Can you guys, whether you saw this last year or not, can you guys please tuck this in? Let's put it right in here. You cannot square root a negative. Exclamation points. And we don't even need to go to the second zero because we're going to get the same thing. We're going to get an error. This is where the formula breaks down. If there are no x-intercepts, you don't want the formula to tell you there are some. So that means when you use the formula, you will get a negative under the square root. That's the key to telling you, okay, this one will have no x-intercepts. You try to find them, it spits out a math error, you're like, aha, it must be a situation like this with no x-intercepts. Those are the three cases. We're going to summarize those right now. Now, the first one we did had 2 x-intercepts. The second one we did had 1, and the third one had 0. Discuss with the people you sit with. There's, of the 3 bits of our quadratic formula, one of them was very key in determining how many x-intercepts we had. Can you guys have a little think on that? I'll pause the video for a sec. You at home can think on it too. Yes, it was the minus 12. The b squared minus 4ac is the important chunk that will tell you right away, I'm going to have 0, I'm going to have 1, or I'm going to have 2 x-intercepts. Here are the 3 cases summarized, and this term will be familiar for the 2D people. You guys learned this term last year. That b squared minus 4ac part is so important, it gets its own special name. It's called the discriminant of a quadratic function, capital D, b squared minus 4ac. We call that the discriminant. And there's 3 cases to consider. I'm going to kind of divide this space up into 3. So, point 1, let's say you calculate the discriminant, and it is a positive number. When you use the formula, you will add the root of that number. You will then subtract the root of that number, and you will get 2 different things. It will give you 2 x-intercepts. As soon as you know that that discriminant is positive, you can expect to get 2 x-intercepts. And you will also know what the graph looks like in a way. The only way that can happen is if you have a parabola that opens down with its vertex above, or a parabola that opens up with its vertex below. So positive discriminant, b squared minus 4ac is a positive number. You add one thing, you subtract another, 2 x-intercepts. Bingo, bango, bong. All right, second case. This was our second example there. You calculate the discriminant, and it was equal to 0. That means you add 0, you subtract 0, it gives you the same thing. There is 1 x-intercept. What does that look like for the quadratic function? That's where the parabola just kisses the x-axis. A little love tap, and then goes back up like that. Little caress. All right. I'm running out of adjectives. All right, third case. The discriminant, you calculate it, you're doing your quadratic formula, and you get a negative number. You can stop because there's no x-intercepts. You know that for sure. You know that your graph would look something like this. Opens down, vertex below, or opens up, vertex above. Those are the only possibilities. You guys now know everything there is to know about the quadratic formula. You know the important bit, the discriminant, or the 2D people have reviewed it, but we're now on the same page. What we need to get to by the end of today, well, the 3 people, the quadratic formula needs to be automatic. It needs to be to the point where you almost can turn your brain off. Like, I see a quadratic equation, I can find the roots of the x-intercepts without too much brain power. So we can spend the brain power doing the 3U stuff. 3M people, first time using it, you guys get a day to get comfortable, tomorrow to get more comfortable and do an assignment, and then after that, you guys have to be comfortable, automatic, using the quadratic formula. All right. Can you guys finish off with this exercise while I pass around some practice? I don't want to know the x-intercepts for these three. All I want you guys to do is calculate the discriminant. Just do the b squared minus 4ac part, and then say 0 in x-intercepts 1 or 2. So just calculate d for this one.
Yeah, but it's always much easier. Hey, wait, I did it when I finished practice. So we're gonna
Did you guys get 0 for the first one? So you guys are out in the wild solving a quadratic equation. You get the discriminant is 0. You know one solution or one x-intercept. Minus 2 squared is 4, not negative 4. Negative 24, no x-intercepts. Did you guys get that too? Oh, blank stares. Oh no, I got a nod? Okay, I got a nod. We're good. And lastly, I bet it's 2. I bet it's 2. Careful with negatives. Negative 6 all squared is positive 36. Still be careful with negatives. Negative 4 times 5 times negative 1 is positive 20. So you should get 56. I expect some of you guys got 16. So just be careful with the negatives. The discriminant is positive. There are 2 x-intercepts. Did you guys get that as well? All right.